Chris. I'm from Stitch. I'm going to talk about a lot of similar subjects that Roy just talked about, but I'd say we're as you may be able to tell from the title here, taking a maybe slightly less aggressive approach to containers, which maybe will resonate with some folks. So to explain that a little bit, let me just sort of tell you a little bit about myself. I'm just generally skeptical of trendy things, not talking about anything in particular here, but I've been doing this long enough to know that the bandwagon can empty very quickly. 5 years ago, if you weren't on Hadoop, you were stupid, and you don't really hear that so much anymore. I thought I had to go build out this Hadoop system to process a bunch of data, and about 18 months into it, started looking around saying, I don't really understand why I started this. So that sort of engendered a general sense of a little bit of skepticism in me. I'm also really scared of complicated things. Again, not talking about anything in particular here, but complicated things, sure, they're fun to play around with, but if I'm talking about productionizing something, I want to really make sure I understand it. So if it's complicated, it's just harder for me to understand. So just so you understand a little bit about me, that's sort of explaining why, we did take a very slow approach to containerizing. However, we are just about to go to production with a containerized service. So despite my skepticism and anxieties, we did actually find our way there. So I'll just tell you a little bit about how we got there. So real quick, just to give you the context, what is Stitch? Hopefully, if our marketing team is doing their job, this should explain everything. Stitch is an ETL service. Helps you get data from wherever it might live into a data warehouse. So this is why we built Stitch. You can't read any of this, I'm sure. This is a map of all of the SaaS tools that exist just for marketers. And if I understand correctly, there are 4,000 to 5,000 of them in there. And this was as of last year, so it's probably twice that now. There's a lot of data out there. If you're using, if you're a company, you're probably using a lot of these tools. One of these tools is a tool for managing the subscriptions for all the other tools. So there's just an insane number of SaaS tools. And it's a good thing, really. I mean, I'm really glad I don't have to go figure out how to build a messenger application to talk to my customers. I can have one of the very many services that does that just handle it for me. But at the same time, it means that my data is siloed into that service's API. That's a problem we're trying to solve. So our goal, help you get data from one of those services or your database all under one roof in a service like Panoply, a data warehouse like BigQuery or Redshift, or just a vanilla Postgres database. We also use Stitch ourselves quite extensively. As I said, we have a lot of SaaS tools that we use. I think we're probably somewhere around 30. So yeah, we dog food our tool extensively. This is what our tool looks like if you log in. I mean, this is pretty much the entire tool. It's a really simple thing. Yeah, you can see here we sync about 60 million rows a day from our various services into our data warehouse from all sorts of different places. This is all the integrations we have. Facebook, Google Analytics, Close.io, Segment, Delighted. Then we run microservices, so each microservice has its own database, which is great for scaling the database for that service, but sucks when you want to go do analysis on your whole data set. So we pull all the various databases into one single data warehouse. We also use a service called Zora for billing, pull all that in, gives us a comprehensive look at our business. So we build Stitch. I'm on the engineering team at Stitch. We use Clojure, and we write microservices probably in a little bit more of a traditional sense. One JVM per machine, thrown behind a load balancer if it's a web service, and we deploy it with Chef. We run it on AWS. Pretty vanilla stuff. This is a little bit of a look at what our architecture looks like. I'll run through this real quickly just to kind of give you an understanding of what the data path is. at the front is this web API that just basically accepts JSON. And we have some processes that are more or less just ETL scripts that will talk to an API, will talk to a database, pull the data based on a configuration that a customer has entered into the web UI, and send it to this API. And this API then batches the data together, puts it onto a queue, and priority number one for us is durability. If we say that we got your data, we don't want to lose it. So the other priority is availability. We always want to be able to say we got your data. So this API we call the gate. The gate passes data into what we call our fat queue. It's just a Kafka queue. Kafka, pretty much the air that big data breathes at this point. And then that queue, because we have hundreds of clients using that API, we then have a layer called the streamery that demultiplexes the data, right? So that queue has data that's intermingled between all of our customers and all of their various data sets. We then have a layer that just demultiplexes it out into separate data sets. And then we store it on S3. S3, great, super reliable, super durable. And then we have a bunch of processes that go through and look for the data on S3 and say, oh, I've got data to load. OK, well, this data is for my BigQuery warehouse. All right, I'm going to go load it into the BigQuery warehouse. That's pretty much it. It's pretty vanilla. We spend a lot of time worrying about, as I said, durability and availability, and also scale. We've got, in reality, most of these data sets are not traditional big data sets. Our subscription data is on the order of thousands of rows, right? Like not big data at all. But when you amortize it across all of our customers, we're talking about billions of rows a day. So the problem that Stitch is trying to solve right now is how can we integrate with everything? I won't rewind, but right, the 4,000 to 5,000 services in that infographic, we want to be able to integrate with all of them. So this is our own data. And what we found is, so our customers, this is kind of your classic long tail problem, right? Our customers, we give our customers the ability to request an integration if we haven't built it yet. And this is what the distribution looks like. And this is actually only for 2 or 3 months of data. And what this distribution is, it's you're really, you're super long tail. You got one integration that's been requested about 13 times. Notably, we actually already built that one. And then a handful that were requested 2 or 3 times. And then a whole bunch, and I know this is about on the order of 150, that were only requested once, right? So someone, maybe it's their own custom data source, or maybe it's just this really niche API that they use for some very custom marketing data. So we want to be able to say yes to all of these requests, but business reality is we can't have an engineer on our team go and build each one of these things. We would be bankrupt in no time. So our solution to this problem is the Stitch platform. This is something that we're going to be launching on March 1st. So this is a little bit of preview both of what that is and how it works. So the requirements for the Stitch platform were these. We wanted to be able to run one of these ETL scripts to talk to any random API or database on a schedule. Run it every 5 minutes, run it every 15 minutes, run it every hour, run it every day. We wanted the scripts to be able to be built by anyone in any programming language. Our goal was really to make sure to solve this problem by letting other people do the work for us, or for themselves, really. So in doing that, we didn't want to really have to say, hey, yeah, you can build an integration to Stitch, but you need to write it in this Java framework, right? Because A, no one would want to do that, and we didn't really want to do that ourselves. So we wanted to be able to support multiple programming languages, ideally any programming language, and we wanted anyone to be able to do it. Sure.
But if it's traditional ETL, shouldn't it be run on SQL?
I don't know if I honestly don't know the definition of ETL. I know it's used in a ton of different contexts.
But that's what you use here. You said managed by SQL.
I don't think that's a definition. I mean, ETL means extract, transform, and load, right? So I know it means a lot of different things to a lot of different people. I honestly try to get away from using it because it means so many different things to so many different people.
It used to mean one thing for decades. Now, during last 2-3 years, because so many other people got into this business, it started to mean many other things. But it used to mean very,
Yeah. Our approach is actually probably pretty in line with that. Like we actually don't do transformations in our product. We encourage people to do them in SQL. SQL is not really an appropriate language to write extraction scripts against an API. So that's sort of the end of the problem that we're trying to solve. So we wanted our users to be able to develop and test these things locally. Like it would suck if you built a script and didn't know whether or not it worked until you submitted it to us and we ran it 5 minutes later. We really wanted to make sure that all the scripts were isolated, right? Like we couldn't have one person's script segfaulting another person's script, or worse yet, leaking data into another person's script. And finally, like the thing that we were offering to our customers is, if you write the script, we'll run it, right? We'll run it on the schedule, we'll run it reliably, we will scale it if necessary. You don't have to worry about hardware. So we wanted to be able to load balance and place the jobs automatically and scale our system when necessary. So despite my skepticism, I have to admit that Docker is really good for packaging. If you give me a Docker file, I know that if it runs for you, it's going to run for me. It's also widely used, which is really the thing I'm skeptical of, but it's actually a good thing in this scenario because we wanted a lot of people to use it. So it was kind of I'll acknowledge that trendiness can be good in some cases. And finally, right, it's very flexible, right? Like, I don't know that we really care about supporting Windows scripts, but we probably could if we wanted to. But if nothing else, if you're running a version of Fedora and a super old version of Python, we can package a Docker container that will support all that. So came around on Docker for this reason. Containers in general are really good for sandboxes. So you can, through the magic of Linux C groups and memory constraints, you can say, hey, here's a container. It only gets 2 gigs of memory and a fraction of a CPU. It's also nice that you know that these containers are only running a single process. You're entering right into that process. You don't have to worry about confusion about who's starting the process and what else might be happening inside of the container. And they start quickly, which is great too. My asterisk here is really important. One of the things we had originally thought about doing was making this platform available to anyone to just submit a script. And by anyone, I'm not talking about anyone on our development team. I mean anyone in the world, to just submit a script and run it in our infrastructure. That's something we might do one day, but the security implications of that are really scary. Roy was talking about the Docker socket and the various things. In a nutshell, a Docker container is not secure. And you have to go to pretty great lengths to make it secure. So we decided, instead of delaying this launch until 2018, to just say, for now, we're going to code review these things and make sure that there's nothing malicious going on inside of them. Finally, I have to admit that integration of scheduling and infrastructure, which is what Kubernetes and these other orchestration tools do, is pretty powerful. We've written a lot of services in the past where we sort of built a job management system that wasn't tightly integrated with the infrastructure, and it always became a huge pain in the butt when we had to go scale it, right? You'd have to either emit a lot of metrics into CloudWatch or something similar to wire up the auto-scaling, or scale it manually. So tight integration between sort of a job management system and a job scheduling system and the infrastructure layer gives you a lot of power to handle failure intelligently, to elastically scale, and to have some visibility between an event that happened on a machine and the events associated with that machine itself. So came around on Docker and containers and Kubernetes for those reasons. This is what we came up with. And so if you're an outside developer that wants to write against, wants to make Stitch read data out of your brand new API, right? And we would love nothing more than the owners of APIs to actually write these things, because hopefully that means they actually know how their API works and they got it right. But what you can do is you can write a script, any language. We are writing all of ours in Python, but for a lot of the reasons we talked about earlier. But really, we can support any language you want. Run it locally, test it, do all of your normal development processes, submit it to us for review. As I said, we're not quite yet ready to say, yeah, just shove it right into our infrastructure without any manual process. And part of the review will be us packaging it up into a Docker container, right? You can just tell us, hey, here's sort of the Docker image that you need to use, and we'll go from there. And then we also then will just add it to our interface, because ideally we want all these things to be available to all of our users, right? If your brand new API is used by more than one person, we want that person to be, the other people to be able to pull data out of it as well. And so a Stitch user can log in and sort of create a new integration just like any other user would with any other integration. The fact that it's built by not a Stitch member of the team is irrelevant. And so what's happening under the hood is a user comes in, says, hey, I want to integrate with your brand new API. Great, I want it to run every 10 minutes. And here's some configuration. We create a Kubernetes cron job. This is actually a brand new API in the Kubernetes system. And you give it a cron string, like run every 5 minutes. And we pass the configuration into it with a little JSON file. And that's basically it. We also have sort of auto-scaling systems running in our Kubernetes cluster to take care of scaling and so forth. So that's how the platform's going to work. That's going to launch on March 1st. At the same time, we're also going to be announcing an open source project for ETL scripts. As I said, all Python scripts. And the scripts actually just pull data out of APIs. I'm using the word ETL colloquially there. We are also planning to continue to invest in Kubernetes, but I do remain skeptical of the idea of having Kubernetes run our entire infrastructure. Seems very cool. Like you can have, we have it running on AWS, and you can have Kubernetes go spin up an elastic load balancer for you and associate it with a security group, and really, it's fully integrated with AWS's APIs, which is not something I knew until we went down this path. The complexity level there goes way up, right? You then get these virtual networking layers that can exist on top of Kubernetes that will sort of manage the interlinks between the containers. None of our containers need to talk to each other. They're all totally independent processes. So there's a lot of stuff there, really interesting. Kubernetes is moving at a lightning speed, so I'm really interested to see where it goes. But it's also very complex stuff. So we're sort of, I think we dipped our toe into the pond with this project. I'm very happy with how it came out. It was a really good infrastructure tool and container management tool for the job. But I think we're going to think a little bit longer before we dive completely into the deep end of sort of full-on, manage everything Kubernetes with Kubernetes. So that's all I have. Any questions? Yeah.
So I was kind of curious about what you guys thought the advantage of Kubernetes was versus like EC2 container storage, like the built-in. So what was the compelling?
Yeah, honestly, it was kind of two very simple things. One was just strength of the community and backing of a very large company. And well, obviously, ECS would have the backing of a very large company too. The real thing was Kubernetes has a little bit more full-featured APIs, particularly with the scheduler. That cron job API does not exist in many of the other schedulers. You can hork on additional systems to handle it, but it was really kind of out of the box exactly what we needed. And we had also sort of based on some research understood that the scaling capabilities of Kubernetes are as good as we would need them to be. So we felt like it was a good choice. And I think if we had had more trouble getting Kubernetes up and stable and getting confident in it on AWS, we probably would have thought twice. But that turned out to be pretty easy. I think Google, the documentation on Kubernetes is extensive, but not always super clear, but the tooling is really nice, right? There's a lot of great tooling to deploy it to AWS or some other infrastructure, and it'll kind of take care of a lot of the nuances for you. That said, we actually, when we were prototyping this, we prototyped it on Google Cloud, because even though it didn't take us very long to get Kubernetes up on AWS, it took us literally 5 minutes to get it running on Google Cloud. Yeah. Any other questions? All right. Thank you very much.